Okay, so in this first example, we are talking about trajectory type problems. So with a trajectory problem, I always think it's easier to have the picture drawn. So we have a building and the students are firing a ball off the top of the building. Here we go, and there's the ball. So right here, you should be able to see, or I want you to see, that there is a trajectory motion. This is the building right here. Okay, so the ball goes up in the air and then comes down, and obviously the ground is down here. Okay, so we're using the formula that well, actually in this problem we're not using the formula that is given right here, because they tell us that this is actually the formula that we're going to use to determine the height. Okay, so the physics students fired a ball off the top of the building and tracked its height above the ground. They then modeled the height in meters above the ground as a function of time in seconds since it was fired. And the equation they determined was this right here. How long was the ball in the air? So what we're looking for is how long from this point all the way until it hits the ground. This looks like ocean down here, but this is really the ground. Okay, so pretend that we see the ground. So this is actually what we are looking for here. Okay, so this is the type of problem where we're looking for roots or zeros. Okay, roots or zeros. Okay, because if you picture that the ball starts here or whatever, yep, the ball starts here and it lands down here. We want to know what is this x-intercept. So in order to do that, we set the function equal to 0. So 0 equals negative 10t squared plus 15t plus 25. And the question is, how long was it in the air? So we're looking for time in this case because it's asking for how long it was in the air. We're not finding the vertex, we're finding how long it was in the air. So from this point until when it hits the ground. Okay, so we factor. So 0 equals, and I'm going to factor by grouping. You can factor any way that, that you are used to. I'm going to factor out the negative 5 first, so 2t squared minus 3t minus 5. And then we should see that this is the factoring. So we have t plus 1 and 2t minus 5. Using the zero product property, I know that t plus 1 is equal to 0. Or 2t plus 5 is equal to 0. So when we solve, we have t equals negative 1 or t equals negative 5 halves. Well, clearly doesn't make sense to have negative time. As much as we'd like to go back in time, we cannot do that. So the answer to how long the ball is up in the air is negative 5 halves. Okay, so what you will do, negative 5 halves seconds. So what you will do now is you will stop this video and then go do the very first problem.